Hey, it has been a while since we've had a Lefkowitz on stage at this conference. This year we have the younger one, it's Glyph. I'm always very interested to hear what Glyph has to say. And today, he's going to be talking about the perfect Python project. Please make Glyph welcome.
All right, should I talk for a sec? There's going to be some louder talking later, so I want to make sure we're calibrated for weird metallic noises. All right. Today I'm going to be talking about the perfect Python project. But first, I wanted to mention one of my favorite books when I was a kid. It's called Be a Perfect Person in Just 3 Days. This talk will contain spoilers for this 1983 children's book. I feel like you had your chance. I'm not like skipping or giving timestamps or anything. In the book, our hero, Milo Crinkly, is having a tough time in 8th grade. At the library, a book, the eponymous Be a Perfect Person, falls down on his head. And within it, he finds a set of instructions to go from bullied loser to perfect person. And he follows those weird instructions. This talk is that weird instruction manual for Python programmers. We'll get back to the book in a bit, though. So first, I'm going to assume that we're talking about making an open source Python library uploaded to PyPI. Most of us have proprietary projects at a company or applications rather than libraries or both. Mostly applications and proprietary software are subsets of things you need to do for open source and libraries respectively, though. Proprietary code might not need to worry about onboarding or attracting volunteers from the general public, but you still have to worry about onboarding processes for new employees. Internal libraries may need a slightly different configuration since they're deployed to an internal package index rather than PyPI, but they've still got to be uploaded. Applications may need a slightly different deploy pipeline than libraries since they're deployed to users' computers rather than a package index, but you still do have to deploy them somewhere. And you might not build binary wheels to pip install, but you will still need a build pipeline. So these similarities show us that ultimately all Python software probably has roughly similar aims. You've got to produce reliable software that has as few bugs as possible. You need automated tests to ensure that. You need to produce performance software that goes as fast as possible. You need to have easy-to-read, consistent code. You need to have a project that's easy to contribute to, both for new junior developers doing simple things and for senior architect-level developers doing more complex and significant refactorings. You also want the project to be well-documented, easy to understand for its users, not just its maintainers. You want to deploy quickly and with a minimum of manual steps. You want to have clear expectations of the workflow of the project and a safe environment for everyone to contribute to it. There are lots of talks about blog posts about adopting this or that tool and doing some basic initial setup, but I want to be comprehensive here and show everything that goes into the perfect project. So that's a lot of stuff. Better get started. First, basic project structure. You will need to put your code somewhere. Practically speaking, this means you need a GitHub repo. The first file in that repo should be a pyproject.toml that describes your project. You need to say what your project's name is and what its license is. Trove classifiers can help you say other stuff about the project that can be discovered via search, sort of like hashtags for Python project discovery. You got to make sure you indicate what Python versions your project works with, of course. Then you need to list the packages you depend on and any limitations on the versions that you work with. I'll talk more about versions later, but in your pyproject.toml, you should generally avoid pinning exact versions. You should just sort of say which ones you know that your project ought to work with, so people can try upgrading without having the tools prevent them from doing it. You'll need to select a build system. You can use Hatch or setup tools, but Hatch is the new cool one, so let's start with that. You can add optional dependencies. These are specified in a build system specific way. Since we've chosen Hatch, we'll use the intuitive tool.hatch.metadata.hooks.custom.optional-dependencies section. Then we should specify any scripts that we want to expose as command line tools. Here we expose hello as running the save function in the hello.main module. There's a ton more stuff you can put into pyproject.toml. But we really need to move along to talk about code quality. You need to run your tests automatically when people submit code in order to make sure that any contributions work properly. For the purposes of this talk, we'll assume that continuous integration means GitHub Actions because it's free and it's cross-platform and it's mostly good enough and we just don't have time. But, of course, you don't have to run anything to run continuous integration if you don't have a test suite. You'll need to write some unit tests. A little out of scope for this talk to explain how to do that. So suffice it to say, you need some, and you should probably write them with PyTest. You will also need a runner to run your test runner to ensure that it has all the right dependencies and runs all the right versions of Python so you can test in more than one configuration. For that, you'll need to set up Tox. Tox is going to need to have its own separate configuration file outside of pyproject.toml called tox.ini. It's also in a different and worse syntax for arcane historical reasons. And remember how I said that you listed your supported Python versions using trove classifiers? It's time to list them again, but in a slightly different format in your env list in your tox.ini. You can pip install Tox locally and run your tests now. But what about in the cloud on each of your pull requests? Time to set up GitHub Actions. This mainly consists of writing a YAML file because, of course, every new configuration file needs to have a new syntax. So this is different than both pyproject.toml and tox.ini. As with every tool, you need to list your supported Python versions again in a new format that's different than both pyproject.toml and tox.ini. You also need to do this because both Tox and GitHub Actions specify a matrix in mutually incompatible ways, and they're also in different formats. Now that we've got test coverage covered, let's talk about test coverage. Setting up code coverage is important because if you don't have coverage, you don't really know if your tests are doing anything. You may think a PR is tested, but without coverage measurement, it's hard to be sure. The first thing that you need to do is set up coverage.py itself, so your tests run under coverage. First, you need to install coverage. Then, you can run your tests under it easily enough by changing your command line from python-m pytest to coverage run-m pytest or your own custom test runner if you use something other than pytest. If your code runs any tests in sub-processes, you will need to take some special steps to ensure that it doesn't drop that data, which is the default behavior. So it's time for a new configuration file, coverage.rc. At least this is the same syntax that's bad as tox.ini. In order to make coverage of more than one process possible, and also to enable your test to run in parallel, you need to set the parallel option, which isn't the default. You also need to run a little bit of code at startup in every Python process. Coverage suggests that you write your own site-customized.py to do that, but I don't think that's actually a good idea, since getting it installed and avoiding conflicts with other things that you need to use site-customized.py for something else is a hassle. So instead, I'd recommend you add the coverage-enabled sub-process PyPI package to your development dependencies as a package, because that will do it using a PTH file, which will interoperate with other things and doesn't monopolize one particular code execution mechanism. Now that I've got your coverage set up, you actually need to report on it. The most popular service to do this is CodeCov. But CodeCov can be a little unreliable. So back in 2021, Hinek Schlowak wrote a great blog post titled How to Ditch CodeCov for Python Projects, where he discovered how to do just that with a GitHub action from Joaquin Jablon called Coverage Comment Action. But of course, at the top of that post, he's got a big annoying caveat about a change that happened that actually broke it for like a month. So you can't escape downtime entirely. Apparently, code coverage is just going to make your test fail sometimes. There are a bunch of other differences between these two different ways of measuring coverage. We've got to move on. Just suffice it to say there's trade-offs, pros and cons. Now, just because every line of your code is covered, that doesn't mean that your data edge cases are covered. For that, you should use hypothesis to give your tests a random sampling of input data. I do have 2 tips before you start generating all of the inputs to your tests using hypothesis, though. The first is that the default configuration for hypothesis is great to discover bugs, but you don't actually want to discover bugs in the middle of an unrelated PR. The documentation sort of explains how to do it with the settings object, but there isn't a great ready-to-run example that makes your test deterministic in CI and discovering bugs for you automatically in like a cron job or in a local environment. Another quick tip is that you don't want to fuzz the libraries that you're using to process input. You're not testing those, you're testing your code. You need to construct objects that your code is going to process as valid, not to test the validations of the data on its way into your library. But once again, there's too much to cover, we need to move on. Okay, next, you need to set up type checking. I'd recommend starting with Nbpy here, because it is the de facto standard type checker and it supports a number of plugins, including NumPy types and Zope interfaces, which are both very helpful and used in venerable large Python projects. But Nbpy isn't the only option, and in fact, many of your potential contributors will be using Visual Studio Code. And that means they'll be using Pywrite. So you might want to check types at that as well. It's pretty fast, and it's friendly to running in CI, so it's not a big deal. But still, other potential contributors will be running PyCharm, which has its own bundled type checker that's different than either of the other two and mutually incompatible, although mostly kind of the same, which it doesn't really have a name other than code inspections. So the way you get that into your CI system is you install the entire PyCharm IDE itself into CI. Then, depending on what operating system you want to use, you either use pycharm64.exe inspect, inspect.sh, or pycharm.sh inspect. You also want your code to be secure, right? There's a tool called Bandit that scans your code for common security mistakes. To configure it, Bandit has another new configuration file with a new naming convention called .bandit. Of course, you could combine type checking and security scanning with Pyre and its bundled taint checker, Pysa? P-Y-S-A? Not sure how you say that one. Pysa has its own configuration file for describing sources of tainted or attacker-controlled data in taint.config. That's in JSON, so new config file format. I really wish I had one of those little counters that was going up every time we had one of those. Another aspect of security is avoiding vulnerable dependencies, which means you need to update your dependencies regularly. But you don't want to surprise contributors by having them have to process some security update in the middle of an unrelated PR. So you need to keep your dependencies pinned until you do those upgrades on purpose. There are a few different and mutually incompatible ways to do this. My personal preferred way is to use the pip-tools package, which contains the tool pip-compile. Pip-compile can operate directly on your pyproject.toml or on a requirements.in and emit a requirements.txt, which will have exact versions of all its requirements in it. I've also heard good things about pipgrip, which is a similar tool that also emits a requirements.txt, but uses the more sophisticated pubgrub algorithm for dependency resolution and has a few additional niceties. However, if you want a more holistic solution, you could use Poetry, which has its own lock file and a set of tools to manage it, and it also changes what build system you're using, so you have to throw out the stuff that we said about Hatch earlier and redo all of that. Or you could use PDM and throw it out again and redo it all again. To apply all of those automatic updates once you're using any of these, except PDM, which has its own separate thing that you need to run as a different action, you can use Dependabot on GitHub Actions, which will automatically understand the various formats of lock files. In no time, Dependabot can get your pull request page to look like this. Security and type errors aren't the only kinds of errors, though. You also have to worry about code style, and there are a few different kinds of code style to be concerned with. But first, code formatting. That can be resolved with the venerable Black, which auto-formats your code, and let's all just pretend it doesn't have a config file. They would prefer that it work that way, and I'm tired of talking about them. The second, linting, can be accomplished with Flake 8. Flake 8 does sadly have a config file. Even better, you can use autoflake, which, much like Black, can just fix stuff for you automatically rather than bothering you. And of course, in 2024, I would be remiss if I didn't mention that you could replace Black and Flake 8 with additional tools like Rough, which re-implements them all in Rust, and also adds a bunch of other stuff and a bunch of other warnings, including preventing you from ever using the indicative mood in a doc string by default, which is that's a choice. I sometimes like to use the word this, but it's very important that you never use the word this, I guess. We're in Python, we like self. So, you can use the tool pre-commit, which can run all of these automatic fixers as a commit hook locally, making it so you never even commit code with a tool that has errors that never even commit code with errors that a tool could have fixed for you. Of course, it's got its own config file, our second appearance of YAML, .precommitconfig.yaml, which of course not only is a new config file, but has its own new way of specifying dependencies and dependency pinning and automatic upgrades. It has a paired hosted service, precommit.ci, which makes it so that your contributors don't even need to have the hooks installed on their local computers. It'll just automatically push the fixes back for them. Performance is also very important. You want your code to run fast. Now, when I first drafted this talk, this was the part where I was writing about how some tools you have to build yourself and performance testing is really hard. But then this new thing, codspeed.io, came out right in the middle of me writing that. We set it up for Twisted, and they totally fixed that problem. I didn't have time for a new section though, so check it out, write some benchmarks, set some thresholds, and enjoy these sweet flame graphs that show you where your code's getting faster or slower. It's actually quite a lot of fun to use. Of course, you got to document your code too. We value readability in the Python community, right? If you're not already familiar, Sphinx is a tool for generating documentation, and Read the Docs is a documentation generation and hosting website that mostly uses Sphinx. If you're going to use it to generate your docs, you'll need a Sphinx project in your Python project, and you can get started with the included Sphinx Quick Start tool, which will make that project for you, including yet another configuration file in yet another language. These are in Python. We already know Python. You should also be sure to select a Sphinx theme. The default theme, Alabaster, looks great and is totally fine to accept as a default, but a perfect project has a brand identity, and you need to make sure that you've sort of integrated that brand identity with your documentation. Of course, there's no point to having docs if you're not going to be able to read them, so first you should set up a tox environment to allow Sphinx to build your docs locally so that people can read it as they're working on it. You'll also probably want some Sphinx plugins. One that I particularly like is PyDoctor, which can generate some nice API reference documentation with an integrated search along with your narrative documentation. But you'll want to build and host your documentation in the cloud too and read the docs as you covered there. Of course, it's got its own configuration file. It's still YAML, but new extension this time. And of course, Sphinx has its own dependencies, which also need to be pinned, as well as all of the dependencies for any Sphinx plugins that you're using. This is one reason that I actually tend to prefer using pip compile, because at least when I redo all of that work, I can reuse the same tool for repinning everything. You can also automate the building of any artifacts. You don't want to spend a bunch of time doing release management. So first, you want your releases to come along with changelogs. So you should use Town Crier, which lets you write release notes with each PR and then stick them all together for your releases, generating a nice, legible changelog for your users. You should also use the PyPI publish GitHub action, but then you need to set up a custom action that calls the prepackaged action so that you can use PyPA trusted publishing, which can't work with a prepackaged action due to the security policies of GitHub. And I really wish I had time to explain what any of that meant, but there's no time. We've got to move on. Just the perfect project has too much stuff in it. So code quality and automation aren't the only things you need to have for a high-quality project, though. You also need to have governance structures. The first of these is a security reporting process. GitHub requests that you do this with security.md, which is a free-form document that just says what your email address is, I guess. But code security is not the only governance process you need. In fact, GitHub recommends a whole collection of these files. You need to have a code of conduct that tells any contributor to your project about what kind of behavior is acceptable. I'm not going to relitigate the concept of a code of conduct in this talk. As Chris referenced earlier, we've done enough of that this week. You need one. Of course, to have a code of conduct, you also need to have a code of conduct reporting process, an enforcement committee, and I'm not going to talk about how to set that up. You also need documentation explaining how people are supposed to contribute. Another important aspect of governance is how you handle money. You can use tools like GitHub Sponsors and Patreon to collect money from users. And of course, you will need a board of directors and a transparent budgeting process and financials and bookkeeping and tax-exempt status. And I also can't really get into any of that. And at this point, I've said a lot of stuff. But I may not have impressed upon you the emotional aspect of this work. Now, there's a saying, when speaking is not enough, you sing. Now, this is my first time doing this in a talk, and the marching band that I tried to commission couldn't make it, so this will have to be a cappella. Here goes. With apologies to Gilbert and Sullivan, and to the captioners, although no apologies may be enough. I am the very model of a Python project open source. I have a GitHub Actions automated test suite run, of course. I have a linter pre-commit in MyPy checking types for me. If you wish to contribute, sign the code of conduct policy. If you submit a pull request, then you will need a code review, and coverage will need to be at 100% to get through. The branch protection gating status checks that ensure quality. And don't forget to also document new functionality. We build instructional materials with readthedocs.com, and Sphinx and Alabaster, and a slightly snide opprobrium for all those other projects that don't fuss over their style sheets. Or at least the ones who don't pick themes with fancy fonts that look real neat. When you report a bug, you'll need to fill out all the form field slots that we will show to all the GitHub users who click bug report. And if you don't supply a valid value to each one of them, then we may kick it back to you with a polite addendum. With Town Crier to specify what your changelog entries will be, and PyDoctor to make API documentation pretty. And in our Actions YAML, you will find plenty more stuff like this, with many cheerful facts about configuring hypothesis. Your test should be extremely fast and also accurate to prod. Be clear and cheap and useful and prevent all outages, oh God. We had a whole QA department get replaced by unit tests. that are maintained by some guy in Nebraska who does not take rests. I hope you've got a sense by now of what this stuff takes out of you. It's hectic and it's draining, and at times it feels like eating glue. You don't need to do all of it, and in fact, I think you should stop. At least please skip the parts of it that make you feel like giving up. Thank you, thank you. It's a little harder to hit those high notes on stage. Do you remember that book that I told you about at the beginning of the talk, though? Be a Perfect Person in Just 3 Days? As we follow our hero Milo, he begins by reading about the importance of unquestioningly following orders, wearing broccoli like a necklace, in fact, fasting for 24 hours. You know, perfect person stuff. He is let in on the final secret. In order to be perfect, you have to remain perfectly still except for occasionally sipping weak tea and going to the bathroom. Because if you never do anything, you will never make a mistake. You will be perfect, which is to say, perfectly useless. If your project is so loaded up with tests and linters and security scanners and model checkers and performance tests and governance policies and documentation generators that nobody ever does anything but endlessly try to satisfy an army of robots, then your project will be perfect too. Nobody will contribute to it, including you, and nobody will use it, including you, because it doesn't have any features. So this endless pack rat approach to project configuration is not really workable. In the end, Milo learns that you don't want to be perfect, you just want to be pretty good. So let's talk about how to make a pretty good project. Every one of these tools has a cost, and every one has a benefit. The 33 tools on this slide are just a subset of what was already in this talk, and I cut about 120 additional minutes of the material from the first half. You might have noticed I was talking a little bit fast. There is a lot more that we could discuss. Even if every one of these projects had a real, measurable, positive impact on your project, each one will also have a cost, and that cost, for almost all of them, requires constant, ongoing maintenance. You need to think about those costs. So what is a pretty good project? Here's some heuristics that I use. Basic metadata for the project, a readme.md that gives an example of basic usage, a license, a pyproject.toml, so that tools like pip will work with it, and people can understand the basics of what the project is. Unit tests that run on every pull request, so that contributors know if they're breaking stuff. Talks, so that people can run the tests locally with one command. They're discoverable, they kind of know what tools come along with your project, and debug things on their own computers. Type checking with Nbpy. Once you've gotten set up with unit tests and talks, this should be a small additional step, and the addition of type annotations can provide a lot of value. And yeah, people's editors might not match up exactly, but that's kind of their problem. Coverage measurement to make sure no untested code is sneaking past is actually important. Documentation with Sphinx and read the docs. Very basic documentation is fine. You don't need to get PyDoctor involved right away. You don't need reference documentation for every single class, module, and function, particularly if you're not a library with a big public API surface. A code of conduct, though, I should stress that a project is not an organization. If you're starting a new project, opting into the PSF code of conduct and making yourself accountable to that process, which means making it possible for your project to be taken away from you if you violate the code of conduct, is much better than trying to run the whole process yourself. With a new project, or really any project with fewer than like 25 regular contributors, it's unlikely that you can withstand the overhead of actually standing up those governance structures, having regular meetings, processing reports, having timely responses to people with questions. I think the heuristic criteria that I have for a good project are a good start, but they're motivated by my own personal experience with what saves time and what consumes it. And more important are the lists of things you need to do in order to tell if your project is good enough for you. First, you should take this stuff seriously and give yourself credit for it. Setting up a project properly takes time. You're going to have to spend time fighting every one of these tools, even the critical necessary ones. If you're lucky, you'll probably have to negotiate some interpersonal conflicts as new people join your project. If you don't treat it as a core ongoing part of maintaining your project, you'll be really frustrated, constantly rushing through trying to set these things up, and it'll be just constantly frustrating. Secondly, keep track of how much of your time these tools are taking. Maybe even track your time with like a time tracking app to see how much time you or your contributors are spending fighting a particular tool. And if one particularly rarely used tool is like that you've written is hard to test, don't be afraid to just make an exception. Drop the coverage requirement. If a lint rule is wasting a lot of your time, turn it off. It's actually not worth it to support that many old versions of Python. You might see big projects supporting everything back to 3.7. Don't bother. Just support 3.12. Skip everything else. Third, focus on more tools which will do work for you rather than tools which make you do more work. There's no getting away from work like writing tests, of course, but if you need an auto formatter, leverage precommit.ci that'll just push the changes back to your repository instead of failing a check and making people do the formatting on their end and making people order the imports themselves. Don't have a link check that says people's import statements are in the wrong order. Just reorder their import statements. Fourth, every time someone in this community has a problem with a Python project, we add a new tool with its own configuration file, or at least its own section of pyproject.toml. The community kind of needs to come together to unify the interfaces for some of this stuff. Maybe Rough is moving in the right direction here, but we need more stuff at the management layer to like synchronize your GitHub Actions matrix, your Tox matrix, make it so you don't need to have your supported Python versions in 4 different formats, things like that. Finally, a project is not an organization. We are all stronger when we work together. So if you need to accept money, consider finding a fiscal sponsor, talk to the PSF. If you need code of conduct enforcement, again, the PSF's good. If you want your project to have some continuity, join up with an organization like Jazz Band or Twisted does some of this stuff. Finding ways to be a part of something bigger can really take a lot of this overhead and load off of you. Thank you very much for your time and attention. If you enjoyed this talk and you want to support the development of more of my independent open source software, blog posts, and apparently singing, you can support my work on patreon.com/creatorglyph. Thank you very much.